Oxygen Blast technical seminars are an Intertech production. For instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.
Now, I said in that previous little blob of text, if I set things up correctly. Well, here's another aspect of the task parallel library. There's another class called task. And what task allows us to do is it says, I'm going to go ahead and execute a, task, pardon the redundancy, in a parallel manner. And the most common reason that we're going to want to use this approach is to keep the user interface thread freed up. You know, whenever we have any kind of a UI control, a button, the text of a window, a text box, if other threads in the application have to communicate with that UI component, it used to require a lot of hoop jumping because, thread affinity is always there for UI components. Well, what I can do nowadays is I can just fire up a brand new task. So this method right here, process files, assume that that's what's going on back over here. As soon as I do that, now my UI thread is freed up. And when I'm back over here, and I'm actually doing things like updating the caption area of my window with a thread ID, I would actually start to see it update now. If I didn't do this part here, well, I would still have multiple threads processing the image files, but that UI thread would never be updated. So that is also a pretty nice little convenience. No more need to worry about some other hacks we used to do, like anonymous delegates, or actually just making up more thread objects. Now, the first example that I kind of showed you there with the image files, obviously when you're working with the task parallel library, you might say to yourself, well, I have to do a whole bunch of stuff in parallel, but I don't have a for loop, right? Maybe you don't have some chunk of code necessarily that you want to execute in parallel. You just want to be able to say, do these 3 things in parallel, or do these 9 things in parallel. Well, when you want to do that, there's actually a different method on the parallel class called Invoke. And what he wants is an array of action delegates. So instead of manually making those, again, I'll just make use of my lambda syntax. So here, I've indirectly defined 2 action delegates, and they're each pointing to a method that's doing some complex work. Whatever that work might be is irrelevant for this example. But again, just notice here how I have the ability to kind of fire off both of these different methods on different threads now. Now, parallel link is just a natural extension of what we have been seeing. In fact, plink is working with the task parallel library in the background. When link was first introduced in 3.5, part of the way that it got its magic done was through a lot of different extension methods. Remember that an extension method allows you to essentially tack on new functionality to a precompiled body of code. So with 4.0, we have a new class that defines more extension methods. And they're all for the parallel support. So there's a brand new class now called Parallel Enumerable. And probably the most important piece is just as parallel. And that just basically says, hey, I've built up this link query. I'm processing an enumeration of data. And I would like to have as many threads as possible jump into the mix here. Now, both the task parallel library and plink have a built-in cancel framework. So you could also go ahead and set up a cancel token. So maybe, for example, if the user clicks a cancel button, you want all those threads to stop what they're doing and die and go away. Well, that's really simple to set up, and I'll show you a little example here in just a second. But here's just a little look at what Plink might look like. So imagine that I'm here inside of a Windows Forms application. Got a button somewhere in that window, and when they click that button, I want to fire up a new task that is in charge of monitoring that method on a secondary thread. So that's going to keep my UI layer responsive. So what is this method going to do? Well, I just kind of put together an arbitrary example. Let's just imagine I have a really large amount of integers, okay? And I want to go ahead and build up a link query where I go ahead and find anything where the modulo of 3 is 0. Just something that would be fairly processor intensive. So what I'm going to do here is I'm going to go ahead and build up my link query, but notice the extra extension method right here. The container of data, right? So again, the enumerable, so that would be our source. So we just are working with a system.array object. Well, that's where I get that new extension method. So much like the system.link.enumerable class, system.link.parallel enumerable, a majority of these methods here are operating on any object which has support for the generic IEnumerable interface, which the array class does. So, let me actually show you a little demo. I think I have something here. Yeah, I think this is it. Yeah. Let me just kind of show you a little bit about that cancel framework. All right, so down yonder, let's start up here. Okay, so inside of my window, I've declared a form level variable, which is this cancel token. Okay, that's part of the system.threading namespace. So he's been around for a while. What this little token allows me to do is to establish, if I want to have this thing, the thing meaning the task running in parallel, if I want things to stop based on user input. So again, that might be like a button click, right? So I'm just going to call it the cancel token. So now, here's that idea of processing a whole bunch of files in parallel, okay? So this is similar to what I showed you earlier. Remember the parallel.forEach? Little bit different piece though. Instead of just specifying the enumeration of data and a lambda expression to process the data, I'm also going to pass in something called a parallel options object. So you see I made one of these guys up here? And that's where I can say, hey, here is the cancel token that I've created. So that was that member variable back up here. Okay, so now that he understands, oh, this thing might be canceled, I'm just going to start to whip on through all those files again. But notice right here, I'm kind of monitoring. I'm saying, okay, well, if we happen to get cancel request initiated, then I want to go ahead and throw an exception. So that's why I have to kind of say, what should we do if the user says cancel? Well, I'm going to throw an exception. Notice how this is all wrapped up in a try block right here. And what am I going to do? Well, I'm just going to simply put a text message on the window that says, okay, we're done processing all your files now. And this message would basically say, the process has been canceled. Now, how would I actually cancel it? Well, if I show you the code here, pretty simple. I got a start button, I got a cancel button. So if I click on that cancel button, I just have to set that token, again, that's this guy up here, to cancel. And I don't even know if I have any image files on this computer. Let me just try this real-time demo. You gotta love them. Oh, wait, wrong one. Gotta love that too. So we got to go here. So if I have image files on my hard drive, which I don't know if I do, we should see thread IDs change up here. Yeah. Right, see all that? I can cancel. And we can see now that the operation has been canceled. So pretty nice framework on how we can go ahead and get multi-threaded code into our programs with a suspicious lack of actual threading logic. So I hardly recommend that you check out the task parallel library. Even if you're not using Link at work, maybe Plink is not immediately useful to you, but the task parallel library I think is just great. You can really simplify how you work with threads.
For more free learning resources and to see the latest lineup of our instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.